Okay, this is an awesome problem. This is a perfect test question problem. Josh and Bess want to make some real leather basketballs for their grand opening of their sporting goods store. They found a bunch of cheap leather suitcases at the local thrift store to use for materials. Their plan is to make basketballs that are about 5 inches in diameter. So they measured the suitcases. They averaged 27 by 19 by 9, and they figure they will have to waste about 20% of the material. How many basketballs will they get out of one suitcase? So it doesn't really matter how many suitcases they bought. And this is kind of weird. They want you to round the answer to the nearest 1/4 of a basketball. Alright, so we're talking about surface area of a ball is this. Surface area is going to be 4 times pi times the radius squared. So it is going to be 4 times pi times the diameter is going to be 5 inches, so 2.5 squared. We're going to have to round it. So that is going to be approximately 78.5398 inches squared. Okay, now a suitcase. So the suitcase is 27 by 19 by 9. So a picture, let's say it's 27 tall, and then let's say it is 19 wide. Then it's going to be 9 deep. So that's 27, that's 9. So something like this. Okay, so here are the surfaces. I am going to have 2 of these guys. And these guys are 19 by 9. Plus, I am going to have 2 of the left and the right. And the left and the rights are 9 by 27s. Plus, I'm going to have 2 of the front and backs. And the front and backs are 27 by 19s. Alright. So if I punch that in on a calculator, that gives me exactly 1,854 inches squared. Okay, now here's kind of what makes it good. They're going to waste about 20%. So if they're going to waste 20% of that, instead of finding what 20% of that is and subtracting it, I am just going to find 80% of 1854. So 1854, if I times that by 80%, so I'm going to times it by 0.8. 1854 times by 0.8 is 1483.2 inches squared. So you either times it by 20% and then that's how much you subtract off, or you times it by 80% and that's how much you keep. So he's going to keep 1483.2. Alright, so that's how much inches squared of material I've got to work with, and one ball is about 78. So if I divide that by 78.53 blah blah blah, let's do that real quick. So 1483.2 divided by you are going to get, hold on one sec, 0.2 divided by this. Okay, we're going to get approximately 18.884688. So you can make almost 19 basketballs out of one suitcase. That's pretty good. Now they want us to round it to the nearest 1/4. So it is either going to be 18.75 or it's going to be 19. So one of these two. So I guess I'm going to have to take 19, subtract this. Then I have to take 18, subtract this, and see which one's difference. So 19 minus that is off by 0.1153. And this 18.75 minus, if we, it's distance, so it's really absolute value, so I don't really care about the positive and negative. But if I go 18.75 minus 18.88, I get 0.134. So it's actually closer to this. It's closer to the 19 than it is to, well, gosh, that's stupid. Well, if you round it, it's closer, but you don't have that much material to make 19 balls. So I guess we're going to have to round down no matter what we do. So we're going to have to go with 18.75, because if you've got 18.88, you can make exactly 18.88 balls out of one suitcase. We definitely cannot round up and say I can make 19 balls, because you've overestimated. So you have to kind of underestimate. You can say, well, I've got enough to make at least 18 3/4 of a ball. So that would make more sense than rounding it up to 19. Even though it's closer to 19, it would round to 19. But we're going to go with 18.75. Okay, now this one. This is a good question. What is the radius of a sphere that has a volume with the same number of units cubed as the number of units squared in its surface area? So the volume equals the surface area. That's what we're talking about. So let's go to the sphere. Let's figure it out. So the formula for volume, in place of volume, I am going to put, so I want to know when volume and surface area are equal. So volume, I'm going to put 4/3 pi times radius cubed. And surface area, I'm going to put the formula 4 pi radius squared. Okay, so this is strictly algebraic, 100% algebra. Let's see if we can find when this is true. When is the volume of a sphere the exact same amount as the surface area of a sphere? Okay, so here we go. And it doesn't really matter where you start. Let's start moving things to the left and to the right. Let's start undoing things. Let's start solving for r. So if I ditch this 4/3, so it's times 4/3. If I divide by 4/3 and I divide this side by 4/3, that is 1. So now I just have pi r cubed, and on the left, or on the right, okay, now 4 divided by 4/3 is the same as 4 times by 3/4. And you're going to cross cancel, and that's just going to be 3. So we're going to have 3 pi r squared. Okay, now check this out. The pi's, if you divide this by pi and you divide this by pi, pi undoes itself. So now we're starting to get somewhere. and I have radius cubed equals 3 radius squared. So let's undo the radius squared. Let's divide by radius squared, and let's divide this by radius squared. And that is just 1. And 1 times 3 is 3. And radius cubed divided by radius squared equals radius, 1. And that is actually it. When your radius is 3, your volume and your surface area are going to be the same unit. So only when your radius is 3. So that's kind of fun. Just start moving things around from side to side, and eventually you'll get cleaned up to where it's not too bad. Okay, B is the same question. So B is talking about a cube. So all edges are equal on a cube. So what length does the edge of a cube need to be for the volume to equal the surface area? So on a cube, the volume is x cubed. Surface area is 6x squared. So we should have maybe started with this one. This one might be a little easier. Let's undo the x squared. So let's divide by x squared, undo the times, I mean. So divide by x squared, divide this by x squared. And that is just 1, and 1 times 6 is 6. And x cubed divided by x squared is just x. So when your cube is a 6 by 6 by 6, that is when the surface area and the volume are the same. So I guess we should have started with B. B is way easier than A. Alright, example number 4. So it's still kind of the solids thing. Which of the two figures has a greater volume to surface area ratio? The rectangular prism or the cube? Okay, so let's find the volume of this rectangular thing, and that's going to be 8 by 18 by 12. 8 by 18 by 12, that is a volume of 1,728 units squared cubed. So we'll call them inches, whatever you're measuring by. Okay, now the surface area is going to be 2 of the fronts, and the fronts are 8 by 18s plus the top and bottom, 2 of those, and they are 8 by 12, plus you got to add 2 of the left and rights, and they are 18 by 12. Okay, so got to punch that all in your calculator. Two by 8 by 18 plus 2 by 8 by 12 plus 2 by 18 by 12. Okay, did I get it right? So that is 912. Okay, now how you're going to set it up. So they want a ratio, and they want the volume to surface area. You have to put the volume first. So the volume is 1728, and if you go volume to surface area, 1728 to 912, that is the same as, you can express it as a fraction, 1728 to 912, and 1728 divided by 912. That is the same thing as 36 is to 19. And that is the same thing as 1.8947 is to 1. So this is the volume, and this is the surface area. So the volume is almost twice as big as the surface area. It's 1.89 times bigger than the surface area. Okay, now let's do the cube. Okay, the cube, the volume equals 12 by 12 by 12. So the volume is 1,728 inches cubed. Okay, now the surface area of a cube is just 6 of these faces, so 6 times 12 by 12. So if we go 6 by 12 by 12, that is 864 inches squared. Okay, now you have to compare the volume to the surface area, so it's going to be 1728 to 864, or 1728 over 864, 1728 over 864. Oh, that simplifies nicely. That simplifies to 2 to 1. So that is the volume, and that is the surface area. Now look at this. 2 to 1, so your volume is exactly twice what your surface area is. This one is 1.89 times what your surface area is. So which of the two figures has the greater ratio? That's this one. Doubling it is barely bigger than 1.89 timesing it, but it is bigger. So your cube will have the greater volume to surface area ratio. Okay, we're getting close now. Okay, this is a good problem. So it's pretty straightforward. A railroad boxcar is a box standing on top of a flat platform on wheels. Typical boxcar has width 9, height 12, and length 48. So this guy's 48. The height is 12, and the width is 9. So kind of our 3D piece right here. So this width is 9. Okay, now your model. I want to make a model that is 1 foot long. So your model is going to be 1. And the original is 48. So what they did is they took that 48 and they divided by 48. So your scale factor, this guy right here, is 1/48 of the actual size. So what you have to do is take each dimension and divide each of them by 48. So you're going to go 12 divided by 48. That means it is going to be a quarter tall. So it's going to be a quarter tall, and your width is going to be 9 divided by 48. And that is 3/16. So here are my specs. Okay, so question A. I think we just answered it. How wide and how high? So it should be wide, 3/16 of an inch. Or no, what are we talking about? We're talking about feet. So that's 48 feet. So this is going to be 1 foot. So this is going to be 3/16 of a foot and 1/4 of a foot. Okay, what length of steel rod do I need to frame my boxcar? So that's the edges. So I'm going to have 1 foot. How many of these 1 foot edges am I going to have? I'm going to have 1 on the bottom, 1 on the top, and then on the other side 1 on the bottom and 1 on the top. So I'm actually going to have 4 of the 1 footers, plus it's going to be the same for each. Your 3/16 piece, your width piece, there's going to be 1 on the top, 1 on the bottom, on the front, and then 1 on the top, 1 on the bottom, on the back. So 4 of my 3/16, and then 4 of my quarter pieces. So if I simplify that, what does that give me? 4. That is a 4, and that is... This is 3/4 right here. and this is just 1. So 4 plus 1 is 5, plus 3/4 is 5.75. So I need 5.75 feet to frame in that box. Okay, so far so good. C, how much plate do I need to cover all the sides? So that's surface area. So this right here, this side is, you've got 2 of them, one on the front, one on the back. So I need 2. I'm looking at my model actually, so they are 1 by 1/4 plus I need 2 of the front and backs, and they are 3/16 by 1/4, and then I need 2 of the top and bottom. So the very top is going to look something like this. So this piece right here in the bottom, and that is going to measure 1 foot by the width, and that is 3/16. So punch all this in on your calculator, hit enter, and hopefully I'm probably just gonna have to change it to a decimal. I think all these are pretty decent fractions though, so it might not be too bad. So if we go 2 times 1 times plus 2 times plus 2 times 1 times 3/16. Okay, I get that we need exactly 0.9685 feet squared, so almost 1 foot squared of material. Okay, D, how much steel bar is needed to frame the real one? So to frame it, it's going to be kind of the same as B. I need 4 of the 48 footers, plus I need 4 of the 9 footers, plus I need 4 of the 12 footers, and that is a total of 276 feet that I need. Okay, let's keep going. E, how much steel plate is needed to cover all the sides? I need 2 of these. Let's go like this side right here. So it's 48 by 12. So I need 2 of the 48 by 12s, plus I need, let's do the top and bottom. The top is going to be 9 feet by 48. So I need 2 of the 9 feet by 48, and then the very front and back I need 2 of the 9 by 12s. Alright, so if you punch that all in, it should give you 2,232 feet, square feet of steel plate. Alright, F, if steel rod costs 75 cents per foot and plate is $3.25 per foot, per square foot, how much is my model going to cost the materials? So the rod I needed and the plates. So for my model, the rod, that was question B. So I need 5.75 feet. And the plate was almost 1 square foot. It was 0.96875. So this is feet and linear, and this is feet squared. Alright. So the rod costs 75 cents per foot, so I'm going to times that by 0.75. And the plate, I'm going to times that by 325. So if I go 575 times 0.75, so the rod I only need to spend $4.31, $4.32. The plate I need 0.96. I'm gonna times that by $3.25. I need $3.15. Okay, let's check. Does that come out good? So I guess it wants to add them up. So the total cost. So if I add my 431 and my 315, it's gonna cost me total $7.46. Okay, gee, what guess should I put on the cost of the actual Boxcar? Assuming the price is $5 per linear foot and $9 per square foot. So my Boxcar, let's go rod and plate. Okay, the plate I needed 2,232, and I don't know, guess. I guess they want us to round or approximate, but we'll just find the real one. 2,232 square feet, and I'm gonna times that by $9. So yeah, I guess you could times it by 10 and say you need 20 grand. And the rod I need $5. So how much steel bar? I need 276. So actually this might not be too bad. 276, and if you times that by 5, so look, if you times it by 10, that'd be 2,760. But we didn't times by 10, we times by 5, so you need half that. So you divide that by 2. Oof, maybe it is a pain in the butt. If we divide that by 2, that's going to be 1 grand. It's half of 2 grand. 760 is going to be 3. Okay, 350 is half of 7, and then you need 60, so you need another 8. 30, so 1380 for there. And then your plate, if you times it by 10, then you would need 2232. Just put a 0 on there. So guess you could add up and figure it out. But if you do it exactly, so if you do it exact, you need this is going to be, alright, you just add them on your calculator. 5 times 276 plus 9 times 2232. So you need 21 grand 468, and we overshot, so we're gonna end up with like 23 grand. So we got close. So 23 grand would be probably a pretty safe guess. Now what is the volume of the actual boxcar? So volume is just going to be length times width times height. So it's going to be 48 times 12 times 9, and that is 5,184 feet cubed.